Hey guys, today we're going to be looking at the longest palindrome. This is actually a fairly easy problem. Given a string S which consists of lowercase and uppercase letters, return the length of the longest palindrome that can be built with those letters. Letters are case sensitive. For example, a capital A and lowercase a are not considered a palindrome. Okay, and so let's go ahead and look at this first example that they give us. So here we have A, B, C, 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 D, D. And so what this problem is essentially saying is, if we could rearrange these letters, what's the biggest or longest palindrome that we could create with these letters? All right, and so here, what we have is so one thing about palindromes is that they have an equal number of characters. So if we were to look at okay, so this is a palindrome. If we look at this, well, this is part of a pair. This is part of a pair. And if it's an odd length palindrome, the center character, the middle character, is not going to be a part of a pair. Okay, it's going to be a single character. So the length here would be 5, and this would be a palindrome. Now here, we actually have two. So one thing that we could do to solve this problem is figure out how many pairs we have. All right, so here we have a pair, here we have a pair, and here we have a pair. And then over here we have two characters that are not pairs. Okay, so basically what we would do is use buckets and count all of our C's. So here we have 4 C's. We count all of our D's. Here we have 2 D's. And then we would count all of our A's and B's. Here we have 1 A and 1 B. All right. And then we would loop through our counts. And we would say, well, how many C's did we have that were even? Okay. So we would figure out how many pairs of C's we have and then add that result in. So here we had 2 pairs of C's, and we would add that full 4 value for the 2 pairs. We have 1 pair of D's, and we'd add that 2 as the full amount of D's that could be in our target palindrome. And then over here, we're going to say, well, if this number that we counted here, so we have 4 and 2, and we may have some other numbers, or we may not, but we know that we have 6 as part of pairs. Then we're going to say, well, is this 6 less than this length? Okay, well, this length is 8. This is less than that. So we have 3 pairs, but we have other characters that could potentially be a part of our solution as that middle character. And so we're going to say, well, if the number of characters in our pairs is less than this, we're just going to add 1 to that result. Okay, and so 7 would be our answer because we would add it to that 6. Okay, so let's go ahead and get straight to the code. And if we look at that, the output would be 7 because of that logic I just explained. Okay, so what we're going to do here is we're going to create those buckets. And basically, when I say buckets, we're just going to have an array. And so int characters. And so one thing we could do here is we could start our array at 0. And instead of an array of ints that is 128, we know that characters start on, I think, at 40. Yeah. And so we could say, here we could just say 88 or whatever. All right. And then we could just add it, but that's too messy. Okay. So here we're just going to say, well, we're going to take this int array that's 128 and we're going to add the char value. We're just going to update the int array at the char value. Okay, so that it adds to the right bucket. Okay, so here we're just going to say for char c in s.to char array. And then here we're going to say characters at C++. All right, we added it to its bucket. And then we're going to create our result. Oops. We're just going to say int result is equal to 0 for int I in our characters. Then we're going to say result plus equals I divided by 2 times 2. Okay, so basically if the so this is I. So if I is 4, we're going to say 4 divided by 2, which is 2, times 2 gives us the original 4. And so we're going to add that to a result because that's part of our palindrome. Now, if we have 5 characters at I, this is going to say 5 divided by 2, which is going to give us 2. And then we're going to multiply it by 2, which gives us the 4. Because of integer division, it drops off that 0.5, and so you never really see it. And so, because we don't care if there are 5 of them, okay? We only care if there are even amounts of them. And so here, this gives us all the pairs. Now, there may be more characters than there are pairs, and so we're just going to say if result is less than s.length result plus equals 1. And then here we're going to return the result. Okay, so let's go ahead and run code, see if I didn't make any typos or anything. Okay, so that looks good. And let's go ahead and submit. And, looks good. Numbers are good. And the runtime complexity here is O of n. And then the space complexity is, it's, I guess it would be like O of n as well. All right. Or I guess, yeah. So O of n on each, and that would be it. Okay. So if you found this useful, go ahead and like and subscribe. If you saw something that could have been optimized, I'll go ahead and comment that. Or if you saw something that maybe I made a mistake, comment that as well, because I'm always looking to learn. My journey will take me to a top tech company, because I'm actively trying to pursue that. Hopefully you are too, and that is what I am here to help you do. You can join me on this journey as we go through these Grind 75 problems, and we can both potentially work for the same company one day. But if this was useful, like and subscribe. Otherwise, I will see you in the next video.